In this video, I will explain Kirchhoff's voltage law and actually how to apply Kirchhoff's voltage law into electrical circuit. The simplest circuit to apply Kirchhoff's voltage law to is a series circuit, as drawn here, R1, R2, R3. This is a series circuit previously seen by us. Kirchhoff is saying that the algebraic sum of all voltage around any closed loop equals 0. We explained in a previous video what an electrical loop is, closed loop or just a loop. So this is a loop starting from the supply and a simple loop. Since it is a series circuit, only it has one loop, one path for the current to flow. So it is one loop. Now, if you want to apply Kirchhoff's voltage law, you have to do the following steps. First one, I will use always, in all my videos, I will use the conventional current, which is from positive to negative as explained in a different video. So the first thing is, this is the direction of current in the circuit. I assume it from positive to negative. After that, I will keep asking myself, why the current flow in R1? For the current to flow, it must be from positive to negative. In this R2, again positive, negative, and then positive, negative. To apply Kirchhoff's voltage law, you will start from any point you want, any elements of these four, R1, R2, R3, Vs, namely. And whenever you start at the beginning of the element. Let me change the color here. This is the starting of the element. This is the starting of the element, and this is the starting of the element. If I want to start at R1, so I have to start before, assume the current entering the node at R1. So before the current enter R1, I start from here. So the first thing the current will see is positive sign. So it is positive VR1, and then positive VR2, and then as the current go through that circuit, that resistor, it will be positive VR3, and then the current will see negative 90, sorry, equals 0. One important point here, I recommend you to use this subscript method. Whenever I write a voltage, R1, I use R1 subscript voltage, subscripted to R1. So whenever you see this, it means that the voltage drop across R1. If you talk about current, it will be IR1. And always keep this, because this is what I use. And if you start to use this, it will be easier for you to follow me in my videos. Now let me apply Kirchhoff's voltage law before it enters to R2, i.e. the current. So it will be positive VR2 plus VR3 minus 90, and then plus VR1 plus VR2, which is already we have it equals 0. Kirchhoff saying the algebraic sum of all voltages around any closed loop equals 0. This is the easiest way to apply Kirchhoff's voltage law without too much thinking and too much how and why and when. The only thing you have to do, consider the conventional current and you start from any resistor, but whenever you start, you have to start at the beginning of the resistor. Not, for example, if you want to include R2, don't include R2 here. You have to include R2 before the sign. Now, if I want to start at, I started at this one, then VR3, so plus VR3 minus 90 plus VR1, and then plus VR3, and then plus VR3 again. Sorry, R2 here. Enough. I don't need to repeat myself. Third one, if you want to start at the supply minus 90, so your first thing you see is minus 90 plus VR1 plus VR2 plus VR3 and then plus VR minus 90 again. So enough, I don't need to repeat myself. Now if you look at these equations, you find this is R, this equation starts at R2. What about R1? If you go to previous one, you see R1 starting, this equation starts at R1 and the last term is 90 volt. This one we move R1 into the back. In the second equation we move R1 and R2 into the back, and we move everything 1, 2, 3 into the back and so on. So it is the same equation. If you start whatever you want, you will get the same result. I think this is enough for a video. I will repeat the same thing with the previous example in loop, the one I explained in the previous video. Thank you and see you in the next video.